I think we are almost done with inheritance. So we have discussed about many scenarios of inheritance, and we continue with the same today. We try to cover almost all every type of inheritance, like single inheritance, multi-level. I'm sharing my screen. Uh, can you see my screen now?
Yes.
Yeah, thank you. So now let's. Yeah. Yeah, let's get into the game. So this is what we are talking yesterday, and this definitely whatever we are discussing is something really an useful scenario. Multiple inheritance, and that too constructor calling in multiple inheritance, and then we have seen the purpose of super method, right? How super method helps us, how to invoke superclass constructor from a subclass. So these are something really very important scenarios, friends. So high priority topics. So this is what we are talking yesterday, and then multiple is also completed. So now after multiple, we can take the example of hybrid, but uh, it's hybrid means combination of any two inheritances. You got it right. Hybrid inheritance means a combination of any two or more inheritances. So simply speaking, two or more inheritance. Okay, that is hybrid inheritance. That's all. We'll do one thing. We'll try to create a simple scenario of hybrid inheritance. We'll try to inherit. So we'll try we'll inherit A to B and C. This is hierarchical. Again, we try to create one more subclass from B and C. That is D. So this is the scenario we are going to implement. Okay. So now here we have two types of inheritance. What is that? Combining hierarchical plus multiple inheritance. This scenario technically it's like creating a kind of diamond system. So this is a kind of diamond scenario. But of course, we don't have this deadly diamond issue in Python. Why? Because yesterday we had discussed if it is Java, if it is C sharp, there is a situation called deadly diamond problem. And that is why multiple inheritance is not supported. But in Python, we don't have such issue because we don't have the problem of ambiguity here, right? Maybe if you want to understand that, why we don't have ambiguity, because if any duplicate methods are there in parent class, yesterday even I had explained that if two parents have same method, which method this subclass chooses, whichever inherits first in the order, it will try to use that inherit that method from the superclass. That's all. There is no such thing like method ambiguity here. But in Java, in C sharp, or even in C++, this concept of ambiguity issue is there, method ambiguity. In C++, to avoid that, they introduced virtual base classes. In Java, they used interfaces because Java don't support multiple inheritance. I believe even C sharp don't use multiple inheritance, and they also uses interfaces. But Python doesn't have such issue because we address this issue by inheriting. Suppose there are two common methods. I think I had discussed that yesterday. Even now we discussed that. Which method, suppose I have some M1 method in A class, M1 method in B class, which one will be inherited here? C by default chooses method from B class. In that way, that method ambiguity issue is avoided. I think I have discussed this example. If you want, sorry friends, we will revisit that topic one more time. So now this is another scenario. I'm just giving you all different situations that prevail not only in Python, in other languages. So let's implement this example. So implementing is simple because we are not taking too much complex examples. Diamond scenario. Let us take this diamond scenario, which is a beautiful example for hybrid inheritance because it is a combination of hierarchical plus multiple inheritance. So what do we do right now? Let's do it. Let's take the class name as a hybrid. Just a minute. Why this is not come on. Okay, then I'll just modify in the hierarchical inheritance example. So what is that? Let's because it's taking time to create a new file, friends. You got it right. So what do we do? Right click new. Sorry, new array. It's okay then. Let's continue with this file itself. Hierarchical. Anyhow, hybrid means we are implementing this two subclasses, two or more. If you want, you can create how many ever you want. But I'm just taking two from one parent. Already we are doing that here in hierarchical inheritance, inheriting A from A to B and C. And now what do? You inherit one more class D from where? Class D from both C comma B. Okay. Now what do? You try to use properties from B and C or C and B in D class D. Okay. So D of some, you can say some, we'll implement a simple mathematical this thing, addition prod, something like, I'll just apply a division here. So here self dot result 2 by self dot result 1. I'm just doing a simple this thing. Generally, we should return these results. Here I'm just printing it directly self dot some. Okay, div or result equal to. Okay, I'm just adding like this. Okay, dividing that prod by sum here. That's all, and just print it here. But in real time, always what we do is we try to return results from all these methods, friends. Just an FYI. So this is actually now you can remove all this. We don't need this many. This scenario is what a diamond scenario. So this looks like this. This is very popular scenario in other languages, right? And having an idea is always useful for us. So let's just see that with the diagrammatic representation. So here, what is this? This is the class A. Let me just create it. This is the class A. So what is that we have in class? If you see here, friends, init and get a methods. Let's put a constructor here. So two methods are there. So, and we can ignore about constructors. I don't think constructors are inherited. We can call from subclass, that is fine. But this get a whatever is there, this gets inherited. So other concrete methods inherited, but except constructors. So what do we do? Just put this is the method available in this one. Fine. Now we have two more subclasses for A class. What is that? One is a B, another one is a C, and finally one more is this one D. So here this is B class, this is C class. These are all something. Maybe once you go and check in the Google, then you will come to know about all this, friends. Check about diamond problem, all that, so that you can that gives you a very detailed this thing there. So A B is inherited from A and C is inherited from A. And here, if you see, D is inherited from both these two. You can see here. So now you can see this. This looks like a kind of diamond, right? This is a popular diamond scenario. Now in this, you have how this works. See, this is a concrete method, right? This concrete method, whatever you see here, generally, this is leave about what is there in B class, what is there in C class. B have its own properties. C have its own properties, but it is not about B and C. Now you are inheriting B and C from A. Whatever that common properties are there in A are inherited to both B and C. In this example, this get A is inherited to, what is that, friends? This is inherited to B. Similarly, same get A is also inherited to C, right? But we are intelligently, this Python is avoiding this conflict actually. Now B has a copy of get A, C has a copy of get A. Will you agree, friends? Why? Because B and C is inheriting A. The same method of get A is inherited to both B and C. That is fine. Now the issue is with the D. Now D has an ambiguity. This situation is called diamond problem in other languages, but we don't have diamond issue in Python. Why? How? Why? It is very simple. In other languages, D has ambiguity. What is that ambiguity? Which method it should inherit? Here, they either get A from B class, get A from C class, because it has two copies, same copy of method in both classes or both parents. Now, D has ambiguity. Which copy of this both methods should be inherited to D? That issue is deadly diamond problem. But Python address this issue very simple. What is that? When D is inheriting C and B, Python people clearly told whichever class is inheriting first, just take the copy from that method. That's all. That's what Python told. So D tried to inherit this get A from which one? From C class. That's all over. So this is the issue. I hope everybody is clear with this problem, right? But we don't have this. How this is addressed in Python? This is the scenario, and this is a diamond issue here. You got it right, friends. This is a hybrid inheritance example. Finally, what you do, just create simply what you can do, create object for D, D equal to D. Okay, and then D dot start start calling methods from where, friends? From its parent onwards. The first method is the, so you can see if you want, you can call first get A, right? D dot get A. Next one, D dot, you can see here, method from A class, add method. And then dot method, D dot add from B class, this method. After that, D dot prod. After that, D dot div. Excuse me, friends. Okay, now this is, we are done here, friends. Finally run this. We should see some output from all of this, of course, from this one as well, from the last subclass that is due with proper values. So having a value from B class as well as from C class. Right? Let's run this now. Now you can see here. So what happened? Do okay. I'm calling method, not method. I should print that variable. Sorry. Now learn this. You get that. Now you have here. That's all. Finally, something 20,000 divided by some 300. It should be this one. You can check it out, friends. Right? This is the final idea of hybrid inheritance. Also, we have come up with a beautiful scenario, diamond scenario in where, friends, in this hybrid inheritance. I'm sharing this code with you, friends. Let me share this code with you. So let's share this with you. Is this clear to everyone, friends? So I hope you also came across certain important things. This is important, friends. Okay. Maybe this might be one of the famous interview question. Okay, probably people might ask in interviews as well sometimes to understand what is our understanding with inheritance. If someone wants to know the depth of inheritance, people ask these kind of questions to us, friends. Got it? Let's move to the next topic. So what is it? So next after that is so now we are done with all types of inheritance. Next, understanding one more beautiful topic. What is it about this one? Let me just show you about super method. Again, this is also very useful thing. Or constructor calling. So one is a constructor calling in inheritance. That is one thing. And second one is super method importance. Actually, there is something called this constructor in Java, but I don't think we have this constructor in Python. So there is a kind of overloading scenario in Java or C++ or C sharp, but Python don't have overloading, friends. We will talk about all this in polymorphism. The next topic is polymorphism. Why we don't have overloading? That's why we don't have this kind of this thing. But I will try to give some very important insights about this scenario, about this and about super, about constructor calling. These are all something really very useful things here. Okay. So now what do you do? Let us take an example. So right click new a Python file. So constructor test.py. Okay, some issue. Okay. If that, okay, let me enter. User already exists, no problem. I'll take one more name, no problem. Okay, let it be there. Now you just take simple examples, class A. First, I'll talk about importance of this in Python. This, we don't have direct this. How this is implemented in Python. So alternative to this in Python, you get this. This is important to this in Python, which is nothing but self actually, right? So we are seeing self every time, but what exactly is self? We should have that a deeper understanding, friends. Let us take a small example. We know, right? DEF, some you say F1, right? You say self. Now, what exactly is self here? I will also talk about few scenarios. What is that? One more important thing I should add here is that is a versus has a. Okay. Maybe you can go when you try to Google or watch somewhere in YouTube as well of different sessions. Whatever we are discussing here, definitely you understand the depth of coverage we are doing here, friends. Okay, this is also very important. I'll talk about all this for a few minutes. Okay. So now talking about self, what is this? This is nothing. What is self or this? In other languages, we call self. This in Python, we call it as self. What is self? If somebody asks you, self is used to point to current class object. This is nothing but this is a keyword which is used to refer to current class object. So self is also a keyword which refer to current class object. Current class means with that A class, current class object. Understanding object level helps you to gain more upper hand on object oriented programming, friends. Right. So now if you just see here, print of, you just say self. When you print self, what is that you see here? Right. We know we are saying self dot sum x equal to 10, self dot sum y equal to sum 20. All this is fine. We set data with self. We call methods with self. That is fine within the class. If it is within class, we use self. Outside class, we use object reference. Right. So point is what is self here. Suppose now you do one thing. So you don't need one more method for this. We are already testing it. Okay. So if you want, you can print this X and Y thing. We done with number of examples. Now what do you do for understanding self thing? Create object for A1 equal to A. This is one object. A2 equal to A. This is another object. Right. Now, even if you want, you can use constructor as example. It's not like it should be F1. Any instance method, even constructor is instance method. Okay. So now run this. So you put a debugger here. Now on top of this, what is that you do? You say A1 dot F1, A2 dot F1. If it is constructor, you don't need to do that calling as well. I'll do one thing. Let me make it as a constructor. So in it, this will be more interesting for us. That's all. Right. Now, when this object A is created, A1 is created at line 9, what happens? This constructor is automatically called, and the object which we created is passed to the self parameter implicitly. This is done automatically. We don't do anything here. This is Python design, not developer design. Now, if you see this, run this now. Let's debug this. It's in the execution mode. Yeah, we can see this now. Now you see here, when I say step into, because this is creating object is nothing but it does an automatic constructor call. Whenever object is created, constructor is automatically called. If you want to see that execution flow, just say step into. Now you see here, when we do this object creation at line 9, this this is also calling this constructor, right? When our object is created, we can see that a constructor call implicitly in the program. Now, while that object is created, while constructor is called, you can see that this object A is passed here. Suppose you do one thing. You also do one thing. You print A1 here and you print A2 here. Whatever you are created here, this same object is passed to the self. Now, anyhow, we are printing self here. That gives you an idea. So step over, right? When we say step over in the console, you can see that A1 object, this is the address of object. At this address, we have that A1 object. Similarly, this assigning x to A1, y to A1, that happens. It's not a big problem. We know all that. We had discussed about parameterized constructors, default constructors, all that. Now, again, get into the another one. Now, A2, it creates altogether a different object for A2. You can see this at the, here you can see here, right? Can you see that? For A2, again, we have a different object. How do I say that this is different? The address of A1 is different, A2 is different. What will be there inside self for us? Self has that address. You can see same A1 is printed when this constructor is called. Again, when you create A2 object, same A2 is printed from self here. You get four outputs finally overall, right? So let me do one thing. You don't need to debug. Run this to prove that that even whatever is self is printing is nothing but the object we are passing when this object is created. Now you can see that, right? Same object. You can see BBO. One we are printing here, one from constructor. And whatever object you created here, same is printed here. Whatever object you created here, same is printed here. This is a clear proof. What is self here? Self is a keyword which holds address of that particular object, of that class, sorry. Okay. So what is self here? Self is a keyword which refers to or which holds address of current class object, right? So that is the idea. So I hope this should be clear for all of you. This time we are going little deep into self now. So a self is a keyword which holds or which refers to current class object. Current class instance, it's nothing but whatever object is this. Now this object is the current class object. Next, this object is the current class object. At that moment, whichever object is there here, that is current class object, which is nothing but a class object. So this is the idea of self here, friends. Got it right? So I'm just sharing this with you. Let me share this also with you. So this kind of object level understanding is also important for you. Maybe sometime later, right? When you are going through a deeper OP, all these things will be helpful for you. Finally, you got about self, right? Self is nothing but it's like a keyword which holds address of that class or object of that class. Okay. So this is the idea. Next after this, one more thing. So what is this is about self keyword, that is fine. Next after that, so isA versus hasA. This is important. So after understanding self, what is that isA? All these inheritances we have discussed. This is isA relation. B is a subclass of A or A is a superclass of B. This is how we call technically inheritance. Inheritance is nothing but is a relation. What is has a relation? Let me just show you. So I will talk about the another wonderful scenario. What is that scenario? So let us talk about it as a test. Okay. So you take one class here A. You set some data to that with, if you want, you can define a constructor. Let's take a constructor. If you want, you can take default or parameterized. It's up to you. So set some data to class A. Self dot x equal to some 10. You know by now, so what is self? Self holds or refers to current class object, which is nothing but A object. And these variables, whatever we are creating here, go and sit inside that class object. Okay. So now I will again show you a pictorial diagrammatic analysis. If you do that for a couple of times, automatically that will sink into our mind. Not a big deal. Okay. So now what do you do? So this is fine, no problem. This is enough, friends. We don't need to anything. Now what I want is I'll take a B class, class B. Okay, I don't need inheritance this time. But the point is, I want to use properties of A inside B class. Got it right? These properties of A, I want inside B class. If it is inheritance, we can directly use them through that inheritance so that the properties of A are inherited to B. All that we had discussed in last 2 or 3 classes. But now, without any relation between two different classes, I want to use properties of class A in class B. This is very important, friends. How do you do that? Suppose I have DF, I want to do some addition here. This is my method, not this one. DF add, okay? Right, I want to do addition. Right, but addition with how I don't want properties from B, but I want that from A. Then what is that I should do here? I cannot directly say here self dot x here. Even we are not seeing that x inside B class. Why? Because A is different, B is different, and we cannot use properties of one class in other class without having any relation. That relation is inheritance in programming. Now we cannot see x here or even y here. We can't see anything. Even if you try this, this throws error. Right? If you think that this works, you can do one thing. Self.c. You try to print this. Now print self.c. Then you try to run this now. Create object for b equal to b, and then try to call b dot add. Now run this. So you have error here, right? This is scenario, right? Why this error means because X is not defined inside B class, Y is not defined in A class, sorry, in B class. And we cannot use properties of A directly in B, sorry, sorry. Am I audible? Clear, right? Anybody saying
Yes, sir.
something?
Yes, sir. Yes, sir. He just unmuted. That's it.
Okay, I got it. Sorry. So you are getting this right, friends? Why this error? It is saying, I don't know, simply speaking in normal language, B is saying, who is this X? I am assuming this X is from A, but is it possible to have a direct access of members of A in B? Not. Either we don't have any relation, no inheritance. Then, if no inheritance, we can't access it directly. What is the other approach? The other approach is applying hasA relation. What relation is that? hasA relation. Now, having object of A class in B class. What is it? Let me just take you. So, hasA is nothing but, okay, what is hasA? So, hasA is having a object of one class, okay, in another class. So, that is hasA relation. So, something like this, if you want to have a pictorial representation, let me just show you. Sorry, friends. So, this is what is that? This is B class object. Let's take this. So this is B object. So hasA is nothing but inside B, again you have A object, right? So this is what we say that B internally has A object here. what do we say this the relation B has A? That is called has a relation. Maybe if you look at the Google also, all the examples in Google, this is has a relation. Why? Inside B object, you are creating A object. And such relationship, we call it as a has a relation. You got it right, friends. So now getting to this here, right? You are seeing here, right? I want A class object inside B and I want to access this member. Simply what you can do, A equal to A, just create it like this. Okay. Now in this, what is that? This A class object we are exclusively creating inside B. Right. If you want, you can have it in instance scope or in class scope. It's up to you where you want to create it. Got it right, friends? So this is important. This is also possible. Even this is something very much used in development. If you want to reuse objects of one class in another class, this is the approach. We just create that object wherever you want and use properties of that class. Here you simply say, once you say A dot A, you create object for A. Here instead of self, we should say A dot X, A dot Y. Within same class, we should always self keyword. But within another class, we should refer with that reference of that object of that class. Now this time this works. See, this is a kind of has a relation, right? Now we are creating object of A class inside B. Now you can have access to members of A in B with this approach. Now right click run this. This time you don't get error. You got 20 here. See, you are able to sum 10 and 10. You can see otherwise 10 and 20. When you run this, you should get 30. You have 30 here. See, and this is importance of what is that? That kind of has a relation. Using objects of one class in other class without any relation between those two classes. How do you do that? With a kind of has a relation. Got it right? Let me share this example. Means you B has A object inside that here. Maybe you put inside, this is a local one, of course, fine. Maybe you put inside method or inside class, wherever it is. That's a kind of has a relation. Right? So this is very important. This is useful for everyone, friends. If you want to use properties of one class in another class without having inheritance, what is the approach? Then we should instantiate that class wherever you want, and then you should access members of that class, that the instance members, through the reference of that object. So that is what we are doing, and finally we are successful here in that operation. Okay, this is has a relation. These are all very useful things, friends. Okay, next, let me just share this example with you. And also just would like to quickly see, so what is it, has a in, we have already discussed the scenario. Just want to see if there is a different way of has a relation composition. Okay. They are passing something like this as parameters, passing this object as a parameter directly. You can do this example as well. So, okay, if you want same example, we can rewrite like this. Suppose if you want to depict this scenario, this kind of scenario as well, what is that we do? We just pass here to this laptop, we are passing that battery object as a parameter. That is also possible. We can pass anything in Python. We can pass primitive data as a parameter. or collections as parameters. In fact, or as a matter of fact, we can pass objects. Now see here, let me just show you then. So what is that? Here instead of creating object here, remove this. Another approach is you take one more thing. Let us pass A here. Put a parameter A. Now you create A object here. A equal to A. Okay, this has another approach of has a relation. In both cases, see, you put here A equal to A. This is a local. You pass as a reference, even this is local. In both cases, somewhere it has to be passed as a parameter, either as parameter or as an object as a local variable. So right, both are in a local scope. Okay. Now what do you do? Simply you take this another approach of passing objects. Okay. Now you create this one. What is that? A class object and B, and then while calling this one, right, add method, you pass that object A, whatever object A you created to add method, and that is passed to this add method here. And this you don't need to make any change. Only thing we just change it the approach of passing this A class object to B. That's all, friends. Other than that, everything is fine. Almost the scenario is same, but we change it the approach. That's all. Earlier, we directly created A class object inside B add method. Now, same thing we created outside and just passing to add method explicitly. So right click, run this. We get same output. You don't see an item of change here. Everything would be same. Only change is instead of we creating object here inside add method directly, we are using an approach of parameter passing. We are passing object as a parameter to this method, this one. So you can see object as a parameter. And that we are using directly here. This is another approach. You got it right. This is another example of what is this, friends, has a relation. I'm just sharing this with you. So this is also discussed. One of the very beautiful topic, right? With a simple example, we have covered that as well. Next after that is, so we did, these are all very important and core concepts of OOP. I don't know if, and if you can go and check it outside in any website, friends, or any all this, you understand these importances. Sometimes people ask questions, lot of questions and all this in interviews as well as and for certificate exams as well. Okay, next one. After is a has a. Now we are done. Now you clearly know the difference between is a and has a. Is a is nothing but inheriting one class to another class. Such relationship is a relationship. Has a means having object of one class in another class, right? By explicitly creating object of one class in another class, maybe in the method or as a class object, whatever it is, right? That is the idea, friends. Got it now? Now today, again, one more beautiful scenario, constructor calling in inheritance. Right, this is very important, friends. You need to know. Suppose, and also I'll talk about the importance of stack here. What is stack and why do we need stack? What is heap thing I already discussed, right? All these objects, this A object, B object, if are created where in heap. So when you see this example, I'll just quickly again talk about it. So now you see here, friends. So this is A class object, right? Where these objects are created, if someone asks you this question in interview, right? What is the memory area where objects are created? All objects are created. Objects are created where, friends, in a memory area called as a heap. This is very important. okay, created in a memory area called as what? Heap memory. Again, these are all fixed designs. Okay, this is a programming designed by this language experts, not we friends. We are just using as is. Only we are trying to understand the background scenarios that are there. Okay, so now if you come here, actually assume this is heap. Heap is something where it's a place in RAM where all your objects are created. So this is heap, HEAP. There is a concept called, if you remember, heap sorting. You can check it in Google, friends. What is it? Heap sorting. Okay. So what is this here now? This one is a heap. Now what happens? Let us see. Let me just show you quickly. Right? When this object is created, what happens? First, an empty object is created inside heap like this. Right? Object is created for A without anything, empty object. Because at this stage, when we call this create object, empty object is created first with some address. Okay. And this address is stored in your reference. Where it is stored? In your reference variable A. Now this is so this whatever 100 is there, this is assigned, the address of object is assigned to this reference variable. Now this reference variable is pointing to this object. Okay, now but still this is an empty object. Now once this object is created and immediately constructor calls, right? Once this constructor is executed on this object, what do we do on this one? A constructor is automatically invoked. What is invoked? That constructor I'll put here. This is constructor. Okay. What is that constructor? Underscore underscore init. This is invoked. Okay, sorry. When this is invoked, in that constructor, we have two statements clearly. So, sorry. The first one is, what is it here, friends? The first one is self.x. All of you know that. Self.x and say equal to some 10, and the second one self.y equal to some 20. Okay, I'm just showing you again how these objects are created, where they are created. You can see that A class object exists inside heap, no, heap memory. And that object is created here and it is assigned to this reference A. And this A is not inside heap. Somebody asked me this question even few yesterday or day before yesterday. This exists inside something called stack. I will talk about that. I'll show you execution flow of methods inside stack, how it happens. Now when construct is called, when this line is executed, X is added to this object with 10 storing into that this one object. And when line 2 is executed, Y is object to Y is added to object with 20 placed into that object. See, this is what happened. When the constructor is executed here on this object, automatically that object, this object get initialized. Now we have one object is ready here. Next, after that, in the code, what is that you are doing? Creating B class object. For now, we don't have anything. Again, an empty object is created. One more, I'll just show you how this object scenario works in any language, not just Python. Object is created for B class now. So again, one more address is created here. What is that? Assume that it is 200. And that 200 is stored into the reference variable B. What is these references? What are these all these variables? A, B, small b. These are all reference variables which holds address of object. If you print them, you can see address from them, right? Why? If you look at this example, or we did this number of times, the address of objects are stored clearly inside these reference variables. So the this 200 again is stored inside B. Now this is also assigned to B here. Now this is empty at this stage. Now what we are doing on B, again we are calling add method. So you can see now once this empty object is created, at line 13 we are calling add, right? So this is add method. Okay, what is there inside add? We are trying to add instance variables from A class assigned to the instance variable of B. C is from B, this A dot X and Y from A class object, otherwise A class object. Okay, now you see here. So this is a beautiful scenario. Observe this B thing, friends. What is that you are doing here? We have one local variable for copying. So actually this local variable will be in not in heap, this one. Right, because methods execute from stack. I'll show you this beautiful scenario tomorrow. But whatever you are passing this A, that A will be somewhere in this stack actually. If I don't want to confuse you, just remember I'll talk about this tomorrow. Now this is add method, right? I'm just adding that these things. What is that you are doing? So this add method has a parameter of A, okay, and also self. Self means a parameter of same class. It also have add that self is nothing but holding address of B class object. So which is nothing but B. That self internally stores what? Let me just write like this for your this thing. Okay, we don't have brackets here, but just showing self is nothing but it is nothing but B object and another A object. Assume this is a stack frame. Okay, inside this what we are doing, we are saying self dot C equal to A dot X comma. I'll just show you the execution flow. A dot X plus A dot Y something. Okay, you can see this friends. Now what happens is at this line you are calling add method, right? Now this method is this method is called on this object B object. When you say B dot add, right? We are saying B dot add. Then this B is add is called on which method? B object. Now to this add method, what is that? This object which is already there in heap, that is passed as a value. So you can see here now. This reference is 200 is copied to B, for instance 200, and A object is there, right? 100 is passed as a 100 is passed to A. So here A has a 100 in this method and B has a 200. Means if they are if this variable is pointing to 100, 200, B and A is pointing to 100 means they are pointing to the, so this A points to this one, this B points to this one. From method, got it right? So this is what happening. Now they got hold of these addresses of these two objects. Now you say self dot C, right? Self means self works on B object, this one. So C exists here. Self dot C means address of C. A dot X. Now you are saying A dot X means it will try to pick this value from A object, means that is nothing but 10. A dot X. Again A dot Y, this value from A object, that is 20. Alright. This addition happens 10 plus 20. And again, you are assigning it that those two values, values of this object, this one and this one, you are adding and you are copying to C here. When you say self dot C, that self is nothing but pointing to which one you can see here. It is pointing to, you can clearly see that self is pointing to B object, which is nothing but current class object. Self dot C equal to that whatever sum you get here, this 30 from this object, this object is added, 10 plus 20 is added, and finally that 30 is placed into this C. See how beautiful this is. There is a kind of, what is that? We are doing a kind of operation on objects here and getting that data from objects and adding that again, adding it to some other object, that result. All this is happening. And this is happening between objects here. So that is what this statement does. Self dot C equal to A dot X, A dot Y means this value data from this object is added and finally that is assigned to this object. And all these objects you can see they exist inside here. And these variables, whatever are local, all local variables exist inside stack. I'll talk more on that tomorrow. Finally, when you what you are doing when you print self.c, you get 30. Definitely you are seeing 30 right in the console, that console thing, right? So this is console. When you are printing that in the next line, that print sends this value from this object onto console here, where that value is coming from the object again. So this is the overall idea, friends. At a deeper level, this is what this so many, I mean, so many supporting execution memory areas are helping us. One is heap is one kind of this thing, and we have a stack in the other place. Okay, there is something called stack, right? What is stack here? Stack is a place where all your methods executed, right? So that is one more, right? So this is all. There are so many things involved when if one program should get executed. Got it now? So that is the idea, friends. So I believe I shared this example, and this is the scenario: how objects are created, where they are created, and how this data from one object is extracted or retrieved, and how do we copy it to other objects, right? Method execution we'll see tomorrow. In tomorrow's session, I'll give a deep dive into the execution flow of methods, how stack work, right? But that is interesting with the example of this one. What is that? Constructor calling in inheritance, right? And after that, we jump to polymorphism. Whatever we are discussing, all this is required for, for someone who is working into development. Got it, friends? So that is the idea. For today, we'll stop here because we got more into the advanced concepts of OOP. These are all more advanced things. Okay, what is hasA, what is hasA? By now, you should have this difference, right, friends? How to implement hasA. There is one more scenario: copying data from one object to another object. So you can also try this: copying data from one object to another object. You can try this example as well. Another object. You got it right, friends. So this is an interesting scenario, and this happens sometimes when you are working in programming. So try all this, okay? So for now, today we'll stop here, right? That's all for today, friends. I think you got all this right. What is hasA, what is isA, and what else what about self? We also discussed about self today, self keyword. What exactly is there inside self? That address of current class object. Okay, and how we have access to that, and what is heap, what is stack, just an introduction to stack, all that. Okay, is this clear to all of you, friends? We'll stop here for today. Okay, thank you.